going to discuss about the relationship between the volume of a gas and the temperature of the gas. Here a water in the beaker is allowed to heat. Then a balloon which is partially filled with air is dipped into the water. What can we observe here? Is there any change in the volume of the balloon? The temperature of the water increases and along with this, the size of the balloon also increases. That means here the volume of the gas inside the balloon increases. Let's do another activity. Here there is a ping pong ball and water is heating in the beaker. Let's dip this ping pong ball after crush into the water. Then observe after some time. What we can see here, the ping pong ball returns to its initial state. That is, because when the temperature increases, the volume of the gas inside the ping pong ball got increases and so the ping pong ball returns to its original shape. So, based on the two activities, what we can conclude? When temperature increases, the volume of the gas also increases. Okay? You have to get to one thing that here the pressure remains constant. Based on the contribution from these activities, we can explain the observation of the experiment here. Make a hole on the lid of the bottle and pass refill through it. Then take refill and place ink on its bottom part and then pass the refill again through the hole in the lid of the bottle and place this system in hot water. What we can observe here? Ink moves upwards through refill. Can we explain the reason on the basis of the relationship between temperature and volume? Here, when the bottle is placed in hot water, air inside the bottle got heated and its volume increases. Or we can say that air expands and this expanded air push ink upwards and so ink rises. Then remove bottle from hot water, what we can observe? Ink moves down. What is the reason here? Here, when the refill is taken outside, temperature of the gas inside the refill decreases and so its volume decreases and the pressure experienced to the ink disappears and the ink drops downwards. So, what is the idea got from this? When temperature increases, the volume of the gas also increases and when temperature decreases, volume of the gas decreases. It was the French scientist Jacques Charles who found the relation between the volume and temperature. This is called Charles' law. So, what is Charles' law? At constant pressure, the volume of a definite mass of gas is directly proportional to the temperature in Kelvin scale. That is, when temperature is taken as T and volume as V, then V by T is a constant or V proportional to T. When the initial volume of a gas is V1 and initial pressure is P1 and final volume is V2 and final pressure is P2, we can write V1 by T1 equal to V2 by T2. When we know any one of the three quantities among this, we can calculate the fourth quantity. So, let's check this table in which V by T is calculated. Here, pressure is constant. So, in the table, there are three columns consist of volume, temperature in Kelvin scale and volume by temperature. When the volume is 546 milliliter, temperature is 273 Kelvin and V by T equal to 2. Then 600 milliliter, 300 Kelvin temperature, V by T is 2. 640 milliliter oleum, 320 Kelvin temperature, V by T equal to 2. Then 660 milliliter oleum, 330 Kelvin temperature, V by T equals to 2. So, from the table, it is very clear that V by T is a constant. In Charles' law, the temperature is taken in which scale? Yes, it is taken in Kelvin scale. Fahrenheit and degree Celsius are the other two scales of temperature. Okay, Kelvin, degree, Fahrenheit and degree Celsius are the three scales used for measuring temperature. Here you can see the graphical representation of Charles' law. Here temperature is taken in x-axis and volume in y-axis and a straight line is obtained. These are the graphs in which V by T is taken in x-axis and T in y-axis, and also V by T in x-axis and V in y-axis. Here the shape of the graph is obtained like this because V by T is a constant. Based on Charles' law, can you explain the situations given? The volume of the gas inside the balloon increases and so the size of the balloon increases and it bursts. Like this, there are certain situations in our daily life where we can observe Charles' law. In summer seasons, tires of vehicles are not completely filled, since there is a chance for the expansion of the air inside the tire and it causes the bursting of the tire. Next one is the contraction and relaxation of helium balloons according to the surrounding temperature. So, now we understood about the relation between the temperature and volume of the gas. Let's do another activity. Here, football which is empty. Let's fill air into it. What happened? We can observe the volume of the football got increased. Why this happened? Because when air is filled into the football, the air molecules inside the football increases and so volume also increases. Here pressure and temperature remains constant. So, what is the method used to increase the volume when the pressure and temperature remains constant? Yes, increasing the number of molecules. It was the Italian scientist Amedeo Avogadro find this relation between the volume of the gas and the number of molecules. This is known as Avogadro law. So, what is Avogadro law? At constant pressure and temperature, the volume of a gas is directly proportional to the number of molecules. That is, when volume is V and number of molecule is N, V proportional to N, or V is equal to a constant into N, or V by N is a constant. When the initial volume of gas is V1 and number of molecule is N1 and final volume is V2 and number of molecule is N2, we can write as V1 by N1 equal to V2 by N2. Here, when any one of the three quantities are known, fourth quantity can be calculated. This is the graph of Avogadro's law. Here, volume is taken in x-axis and number of molecules in y-axis. So, this kind of a graph is obtained since V is directly proportional to N. So, these are the other graph with V by N versus N and V by N versus V. So, this kind of a straight line is obtained since V by N is a constant. So, we discussed about different laws: Boyle's law, Charles' law, Avogadro's law. Thank you.
And claps.